Okay, this is problem 32 from chapter 30, and the question is to find the energy, electric energy, potential energy between these two plates. The diameter of each plate is 2 centimeters. The distance by D equals 0.5 millimeters. The voltage between the plates is 200 volts. So what is the energy stored, the potential energy stored within this condenser or capacitor? And so the formula for energy, you see, this is the potential energy within the capacitor is half Q square over C. This is the original formula by integration. Now, since we don't have a charge, we can have C, but we are given the voltage. Another form of this equation is this. Since Q is CV, so Q is just CV squared over 2C. Over 2C. Now I cancel out C and C. I will have to C square over 2. So this is the energy. Now also, since I have a capacitor, I know C is a function of epsilon 0. That is epsilon 0. It is proportional to A, inversely proportional to D, the separation between the plates. This is C, like this, and I left with V squared over 2. Now I have A, since I know the diameter, therefore I have X to reduce. D is given, epsilon 0 is given. So let's evaluate what is A. The radius is 1 centimeter, so the area is pi r squared, like this. And so this is 314 times r is 1 centimeter, that is 10 negative 2 meter squared. And so it is 314 10 negative 4 meters squared. This is the area. The diameter D is 0, 5, 10 negative 3, which is the same 5, 10 negative 4 meter. Now okay, so the energy is, so half, let's write all these numbers here. Epsilon 0 is 8.85, then negative 12. This is epsilon 0, and then A is this quantity, 3, 14, 10, negative 4. I don't need to put the units for now. And then V is 200 squared now. And then I have half, that is 2. And I have D, this is D, which is 5, 10, negative 4 meters. 4 meters. So the energy UC, so capacitor, is either the math, and the energy is 1.11 10 negative 7 joule. Obviously this is very small number. Okay, this is your answer. 1.11 10 negative 7 joules. This is the first part of your problem number 32, chapter 30. A. this was the answer A. Now let's answer B. Question B is to find the energy density. I'm going to call it U E like this. Well, it is actually the energy stored in capacitor per unit volume. That means we divide by AD. So that energy density is equal to half epsilon 0 and E. The very important equation. We are going to find the parallel to this in magnetism. Very important, the energy in terms of the field. Let me make a remark here. The energy has no location. It is not something we can locate, but we would like to believe that energy is stored between the plates. There is a field between the plates, and the energy can be stored inside the field. That is really the idea behind. So the energy density is epsilon 0 E squared over 2. Now let's plug the numbers. I know E is related to V, that's V over D. So this is 1/2 epsilon 0. Instead of E, I'm going to put V over D. And the whole thing is squared. Now in this equation, I know everything. So UE like this, density, energy density, is now, let's put all the numbers together. This is D2, this is 8, 5, then negative 12, this is epsilon 0, and then I have V squared, that is 200 volt squared, and the D squared is 5, then negative 4 squared. Now you do the math. So the energy density is equal, my calculation gives 71 joules. Since density per unit volume, I have to put here meter cubed. And so this is your answer.